previous session we have already discussed about the rectifiers as the main block in a power supply system. So what is this rectifier? A rectifier is a type of converter that converts the AC signal into its DC signal. So this is a working of a rectifier circuit. So in this rectifier circuit, mainly based on a special device, we tell the different types of rectifier circuits. That special device is our diode, which we all have come across. We know what is a diode and how it works. So before we get into the details of the main element in the power supply unit, the rectifiers, let us first have a brush up on what is this diode and how it is going to turn on and off. So we know that whenever we speak with a diode, it has two regions. One is the P region and the N region. So in the P region, as we know, we have excess of holes that are present in a P region. Similarly, in case of a N region, we have excess of electrons present in case of a N region. And the terminal across the P region is known as the anode, whereas the terminal around this N region is known as the cathode. And we also know that we have a junction barrier present in between two regions. Now, whenever we say the diode is to be in its on state, we know that whenever we are connecting the anode to a positive potential and the cathode to a negative potential, then what happens? Then this positive potential and the holes present inside the P region, they are like charges. So these holes that are present in the P region moves away from the potential and starts accumulating at this barrier potential. Similarly, here we are going to apply a negative potential. So when we are going to apply a negative potential here, the electrons that are present in the N region is moving away because we know the like charges repel each other. So these electrons break the barrier and makes an electron hole pair with the holes present in the PN junction, and this is when a current is said to be flowing from the anode terminal to the cathode terminal, and this is a state when we are connecting anode to positive and cathode to negative, we call the state as a on state. Similarly, when we are going to give the opposite potentials, anode is connected to negative potential and cathode is connected to positive potential, then what will happen? Negative potential, holes are present, so these have a property of attraction, so the holes are tending towards this negative potential. Similarly, negative electrons are present here in the N region and we are applying a positive potential here. So there is a force of attraction. So all the electrons tend towards this positive potential. So what happened to this gap, barrier potential? It increases. The gap between the P and the N region is high, and because of this the electrons cannot freely move to make a pair with the holes. Hence there is no current flow and the diode is said to be in its off state. So this is how a diode goes on as well as turns off when we are going to apply the different potentials across the P and N regions of a diode. So based on these operations of a diode, we have classified the rectifiers into various types. One is the half-wave rectifier and the other one is the full-wave rectifier. So first let us discuss about what is this half-wave rectifier. So half-wave rectifier, here what we are going to make use is, what is a rectifier? Rectifier converts AC to DC. So we are going to make use of only one half wave that is present in a total. A sinusoidal wave means we have a positive half cycle, we have a negative half cycle, isn't it? So together one positive and one negative forms one cycle in a AC signal. In that we are going to make use of any one half of the sinusoidal signal. So that is why we call half wave, and whenever we are using one half of the cycle, then only one diode is sufficient in order to turn it on. So already we have understood what is the working of a diode. Now let us see how this diode is going to play its role in a half wave rectifier circuit. So we are going to give a 220 volt AC. Yes, we are going to connect it to the supply. So we are going to use an input V in, let us call it as V in. That is nothing but a AC power supply which is having 220 volts. Usually the frequency that we use is a 50 hertz, is applied across the terminals of a transformer to the primary windings of a transformer. Since we are calling it to be a step down transformer, we have to show the number of turns in a primary side as more number of turns. Similarly, at the secondary side of the transformer, since we are showing a step down from 220 approximately to 20 volts, we are going to reduce it. So you have to show the turns ratio as very less number of turns. This is how you represent a step down transformer. Right? Now from 220 volt approximately we are going to get some 20 volt across the secondary side. So this part is the step down transformer. Now what we are going to do, let us use one single diode in this direction. This is the anode of the diode and this side is the cathode of the diode. So this is the direction of the diode that we are going to place. So we have the supply, we have a device to switch it on and off. Then to complete an electrical circuit, we require to have a load element. Let us consider a simple resistor to be acting as a load element. Okay, with some resistance R, load resistance R. So whatever the output we are going to get across these terminals, this is the output voltage. Let us call it as V out. So this is the circuit for a half wave rectifier. I hope you have understood how we are going to write the circuit and its different components. Now during the positive half cycle, let us see what happens during the positive half cycle. So during the positive half cycle, I will write from the secondary side. So during the positive half cycle, let us say this is the positive half and here we have the negative. So we have a diode that is present here and the load resistance that is present here. So during positive half cycle, what happens to the diode? Anode is connected here, cathode is connected and we have the load resistance. So anode is connected to positive and cathode is connected to negative. So we already said that if the anode is connected to positive and cathode is connected to negative, the diode will be in its on state. Similarly, here also in the circuit of half wave rectifier, the diode is going to be in its on state. So when the diode is going to be in its on state, we represent the diode as a short circuit. Short circuit will be represented. Means it allows the current to pass through it and hence the current flows here and we are going to get the output voltage when the diode is connected or in the positive half cycle. Similarly, in the negative half cycle, what happens? Let us analyze that. So in the negative half cycle, here let us say it is negative and this is positive. So here we have a diode and we have connected a load resistance RL. So what happens here? When anode is connected, let us say this is anode and this is cathode. When anode is connected to the negative terminal, what happens? When anode is connected to negative, there is a wide barrier gap between the P and N regions. So there is no current flowing through it. So it is in the off state. So when it is in the off state, we represent it as an open circuit. So in case of an open circuit, the diode is as open. So in case of open circuit, we know that when a device or a diode is in the open circuit, there is no path for the flow of current. So here there is a current flow I, but here there is no current flowing. So will you get an output? There will not be any output. So this is how during one positive cycle and one negative cycle, the behavior of the diode varies. Correspondingly, in positive half cycle we are getting output, in negative half cycle we are not getting any output because there is no current flowing in the circuit. So this is how, let us represent this in the form of a waveform. So now let us draw the waveforms for this half wave rectifier circuit. So first one, what is the input we are going to apply? The input that we are going to apply is a AC signal. So with respect to omega t, AC signal, positive cycle, negative cycle, positive cycle, this continues. One positive, one negative is one complete cycle. So we will write 0, pi, 2 pi, 3 pi and so on. So with some amplitude Vm and minus Vm. Now due to the switching action, during the positive half cycle what happens? During the positive half cycle, because of the conduction of the diode, so let us call this as the diode D1. So because of the conduction of the diode D1, we are going to get an output in the positive half cycle. So let us say this is the waveform for the output voltage V0. Okay. So during D1 what happens? During D1 the diode is conducting and we are going to get an output voltage. So here we are going to get the output voltage because of the conduction, switching action of diode. During negative half cycle what is happening? During negative half cycle there is no path for the flow of current because the diode is acting as an open circuit condition and hence the output is 0. We are not going to get any output during the negative half cycle. Similarly, for the next positive half cycle what happens? Again the diode D1 switches on and because of the switching action of diode we are going to get an output voltage because of diode. And this is how we are going to get a rectified output. So this is about the half wave rectifier circuit. Its circuit diagram, the different conditions during the different cycles of a AC waveform, and this is the waveform representation of a half wave rectifier. Only one half we are going to use it for the conversion, AC to DC conversion. Okay. Now as I told you, already as we have seen in the block diagram, it is an unsmoothened waveform, isn't it? Whenever we say DC, we think of a straight line as the output. But here what is happening? We have an unregulated system. So in order to make this as a regulated smoothened waveform, we have to make use of a reservoir components like a capacitor. So where we have to place the capacitor? Capacitor has to be placed in parallel with the load element. Here the resistor is the load element. So in parallel to this, we have to place the reservoir or a smoothing circuit. So let us see the half wave rectifier, how we can modify it by placing a smoothing filter. So this is the circuit for a half wave rectifier with a smoothing circuit or a reservoir capacitor. Now let us see how it is going to operate. So when during the positive half cycle, as we have already seen, during positive half cycle diode is in the on state, so diode is forward biased condition and hence there is an output across the resistance, load resistance RL. During this time what happens? The capacitor starts charging. So here the capacitor starts charging and we are going to get the output voltage across this. Diode is on, there is a path for the flow of current, so the capacitor in turn gets charged. Now during the negative half cycle, this is for the positive half cycle. During the negative half cycle, what happens? This is the secondary side, that is the input side, secondary terminals of the transformer. The diode is open circuit. Because diode is in the reverse bias condition, there is no path for the current to flow, so the diode is open. Now what happens? Whatever the capacitor had already stored the charges, now it will start discharging through the resistor. Right? Because of this discharging nature, it is a quick discharge. It does not take a long duration of time, depending on the value of RL into C, that is a discharging time constant. The capacitor is quickly discharging and there will be an output available. Not because of the diode, but because of the capacitor, the reservoir element, that is already, it had stored the charges during the positive half cycle, and we know by nature of its basic nature of a capacitor is it has to store the charges, then it has to release back whatever it has stored. That is the basic nature of a capacitor. So during the negative half cycle, when the diode is not functioning, when the diode is not allowing the current to flow, this capacitor discharges through the resistance with some discharging time constant, that is calculated as R into C, and because of this we are going to get a continuity. So now let us see how the waveform changes. Now we know this is the input that we are applying, sinusoidal input. So positive negative half cycle keeps on repeating. Now during the positive half cycle, diode is charging. Similarly, the capacitor is also charging till the maximum value. Now diode is going to go to its reverse bias condition. When it is going to go to the reverse bias condition, what happens? It will slightly discharge up to some value, not fully to 0. It has to be continuous. Again it will continue charging, then again it will slightly discharge. Right? So this is how, see the waveform, previously it was completely zero, a zero line. Again the waveform is discontinuous waveform, ripple content. But here you can observe that the waveform has been smoothened. Why it has been smoothened? Because of the smoothing filter, that is a capacitor filter is acting as a smoothing element. So we are going to smoothen the waveform. This is how, by adding an extra capacitor in case of a half-wave rectifier, the waveform is being smoothened. I hope you have followed how the half-wave rectifier works, and by making use of a reservoir capacitor, how we have got the continuity in its waveform. Thank you.